is equations involving indices. Equations involving indices. Many a time we are given situations where we are going to solve equations that involve indices, and the rules are simple. When two index numbers of the same base are equal, it implies that their indices must be equal. When two index numbers of the same base are equal, it implies that the indices are equal. That's if I have x raised by a equal to x raised by b, you see that their bases are equal. Then it's as simple as cancelling the base because they are equal. Then we can say s and s, and we are left with a equal to b. So what we are saying is that if two index numbers of the same base are equal, then their indices must also be equal. And the converse, if you turn it back, we have the second condition, that when two index numbers have the same index, then their bases must be equal. When two index numbers have the same index, then their bases must be equal. Now that is what we wrote as s raised by a equal to y raised by b. Equal to y raised by a, s raised by a equal to y raised by a. You see that their indices, their index are equal. That is a and a, so it will cancel out. We are left with the base s equal to y. So let me repeat what we agreed on now. That when two index numbers which are equal have the same base, their indices must be equal. And when two index numbers which are equal have the same index, then their bases must be equal. So we are going to apply this to solving some examples. We are going to apply this to solving some examples. And the first question says x raised by 3 equal to 8. X raised by 3 equal to 8. We are already given an index of 3. So our problem here is to get an index of 3 on the other side so that they can cancel out. And how do we get index of 3 from 8? It is going to be 2 raised by 3. So if I have to get index of 3 from 8, it's going to be 2 raised by 3. So what I now have is x raised by 3 equal to 2 raised by 3. Instead of 8, I now have 2 raised by 3, because 2 raised by 3, 2 times 2 times, so we give you 8. So that the index are not equal, which means the base will be equal. So 3 cancels 3, leaving us with s equal to 2. It's as simple as that. So when an index is given, make the other side to have the same base so that they cancel out. Then the base will now be equal for you. Okay, so we now move to the next example. And what does this say?
2x plus 1 raised to power 5 is equal to 243. Okay. Solve for x.
Yes, equal to 243. 2x plus 1 raised to power 5 equal to 243. A base of an index of 5 is suggested here. So the other side, we must make sure we have an index of 5 on the other side. And which number raised to the index of 5 will give us 243? It is 3. Because if 3 times 3, 9, 9 times 3, 27, 27 times 3, 81, 81 times 3 is 243. So 243 can be written as 3 raised to 5. So then 5 will now cancel 5. So you have to think very well and know the number I have to raise to the power of 5 in order to get 243. And that number is 3. So the question now changes to 2x plus 1 bracket raised by 5 equal to 3 raised by 5. Then 5 cancels 5. And on the base, we are left with the base 2x plus 1 equal to 3. 2x plus 1 equals to 3. In which case, 2x equal to 3 minus 1. Remember that when plus crosses the sign of equality. When plus crosses the sign of equality, it becomes minus. So I have 2s equal to 3 minus 1, in which case 2s equal to 2, and therefore s will be 2 over 2. And what is 2 divided by 2? It is 1. So the answer becomes s equal to 1. So we go to